Alright, we've got two more examples. So the last one is life insurance. Life insurance is actually a really interesting topic. It's basically gambling. You're gambling that you're going to die. And the insurance company is gambling that you're going to live. And you're basically compromising to figure out who's going to be right and what's a good balance of how much you should pay them and they should pay you. Okay, so a life insurance company sells a $250,000 one-year term life insurance policy to a 20-year-old female for $200. What that means is she pays $200, and if she dies in the next year, the company will pay her $250,000. If she doesn't die, then she loses the $200, but she was kind of protected in that time. According to the National Vital Statistics Report, the probability that a female survives the year is 0.999544, so extremely likely. Compute and interpret the expected value of this policy to the insurance company. So what that means is that if we were to kind of set up this model again, okay, so what's the event? The event is that she is going to live. That's what we want to have happen, right? Well, if she lives, how much money does she make? Well, she actually loses $200. But what's the probability that she's going to live? It's very likely. It's 0.999544. So that's one side of things. The opposite would be that she dies. Now, if she dies, she gets a lot of money, but she's dead. And it is very unlikely she's going to die. It's just going to be the complement of that, 1 minus 0.999544. So now this company is going to basically provide insurance to many, 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 many people. And what do we expect to have happen if they have hundreds and thousands of people insured through them? Well, we would expect the vast majority of them to live, which means the insurance company is getting their money. But if there's just one or two that die, then that takes a whole lot of those $200 to make up for it. So let's see what the expected value is here. I'm actually going to take that negative 200 and multiply it by its probability of 0.999544. Then we're going to add that with our $250,000 multiplied by its probability, which I'm going to write as 1 minus 0.999544. It's a complement of that. So if I go through and I do the calculations here, what I end up getting that the mean of our expected value is negative $85.90. What this means is this is what the insurance company is going to be making. So the negative means it's what the person is paying to the insurance company. Since it's negative means it's what the insurance company is getting. So in the long run, they expect to get about $85.90 per person employed or insured through them. So that will fluctuate for each person because that's just how it works. But in the end, the insurance company is making money so that they can pay their employees. But what they need to balance there is they want to make sure they're not charging you too much because then you'll go somewhere else. But they need to make sure that they're charging enough that they're still making money. Okay, one last example dealing with the stock market. An investment counselor calls with a hot stock tip. He believes that if the economy remains strong, the investment will result in a profit of $50,000. If the economy grows at a moderate pace, the investment will remain in a profit of $10,000. Still good. However, if the economy goes into recession, the investment will result in a loss of $50,000. You contact an economist who believes there is a 20% probability the economy will remain strong, a 70% probability the economy will regrow at a moderate pace, and a 10% probability the economy will slip into recession. What is the expected profit from this investment? So again, let's look at the different events here. The events are either that the economy will grow at a strong pace, that it will grow at a moderate pace, or that it will go into a recession. Ugh. Now, if it goes at a strong pace, then the investment will bring in a $50,000 profit. So I'm going to put plus 50,000. If it's at a strong, that's still good. It's plus 10,000. But if it goes into a recession, then that's not good. And it's negative 10,000, so they lose some money. So the probabilities for each of those, we're going to look at the probabilities. The probability that it goes into that it's a strong one is going to be 20%, so 0.2. Moderate was 70% the most likely, and then a recession was 10%. So how do we figure out the expected value here? Well, we're going to take that 50,000 and times it by its probability, which is 0.2. Then we'll add that with 10,000 times its probability, which is 0.7. And we'll times that with our negative 10,000 times its probability of 0.1. When we do that, it's going to tell us that our mean of the random variable, in other words, our expected value, is going to be 12,000. What that kind of tells us is it's the expected profit from this investment. Now, that was if you were basically to look at this many, many, many times. Anything could happen with just one. You could end up going in a recession. You could end up making 50,000. But what this is saying is if we looked at many examples, we'd expect you to make about a $12,000 profit, which is not bad. Good tip. Okay, so this is the end of 6.1. Hopefully those examples made sense. Now you need to go into the Math Excel for School and do 6.1. And then we'll go on to 6.2. So I hope this made sense. If not, feel free to email me. We can also try to set up a Zoom time or one of those things. But thanks for watching.